All right, welcome back. We're talking about confidence intervals and we're trying to figure out from some kind of a number, we're trying to figure out the population parameter. So if you had to give one number to estimate an unknown population parameter, what would it be? If you're estimating population of mean mu, you probably want to use your X bar. Okay, and we want to have some kind of a point estimator that is going to be a good estimator. And what is a point estimator? Well, a point estimator is a statistic. Okay, it's something that provides an estimate of a population parameter. And that value from a sample is going to be actually called point estimate. Right? So for us, our X bar from the example of the amount of patients per hour at the urgent care is going to be our point estimate. So what are important things for a point estimate? Well, the couple of important things for a point estimate is, first of all, that you're going to have no bias. There is nothing that takes away from your understanding or from your predicting the actual parameter. Another thing that is important for us is that it's going to have low variability. And those are two very important things. The lower the variability, the better you are going to be estimating. And we obviously do not want any bias that is going to be swaying us away from predicting our population parameter. So in our example, we had X bar, okay, was 16 patients per hour at that urgent care. And do I think that this is the population mean? This is what, if I'm going to take all the hours that the urgent care is open, does that mean that every single hour is going to be 16 patients per hour? Probably not. However, if the sample mean is around 16 patients per hour, I could guess that my mu is going to be somewhere in the vicinity of this point estimator. And what's important is how close is this bit of information to the actual mu. And in order to answer this question, we're going to be looking at how does that X bar vary, and how it varies really have to do with our population. So we're going to take lots and lots of samples and we're going to create the sampling distribution. If you remember, we talked about what is a sampling distribution, and it's going to, if this is my population distribution, my sampling distribution, and remember this was for us, this was a sample of 36 hours, okay? It's going to focus more about the mean, and those sampling distributions are going to be more dense. And remember that the mean of all these X bars is actually going to be the mean of the population. It's going to be centered about the parameter. Remember that the standard deviation of these X bars is actually going to be the sigma of the population, and we are going to divide it by the square root of the sample size. So it's really important that we take a sample size that is going to be fairly large. And the larger the sample, the denser this curve becomes, the more we can fit with a smaller region than the parent population. All right, in the next video, we're going to talk about what is a critical value and how we can figure it out from the Z-table. See you then.